Today's lesson is on solving quadratic equations, mostly by taking square roots. So these were the four methods that we went over before, but again, today we'll focus on square roots. For example 1, let's solve this seemingly simple equation, x squared equals 9. One way of solving this is like we did before. Move everything to one side, factor, and use the zero product property, and we quickly see that we get plus or minus 3. So this is one way of solving that. But the common mistake that students typically make is with x squared equals 9, they just take the square root of both sides and say x equals 3. Well, as you can see, we're missing one of the answers. So another way that you could do it is by taking square roots. But when we take the square root here, the square root of 9 is indeed 3. But the square root of x squared is the absolute value of x. We'll go more into the rules once we learn about indexes and more details about what a square root is. So now from algebra, we remember that when you remove the bars, the other side becomes plus or minus. So this indeed is a way for us to get our plus or minus 3. We want to get both of those answers. Example 2. Let's solve this by taking square roots. First of all, I want to try to get the x squared by itself, or wherever the square is. I want to try to isolate that. So I'm going to add 6 to both sides. And I get 3x squared equals 6. I'm going to divide both sides by 3. Now I see I have x squared by itself. And now I'm going to take the square root of both sides. And I want to make sure you know that whenever you cancel out the square and the square root, okay, so whenever you cancel a square and a square root like that, absolute value, okay? And again, I'll explain that more in detail for you. Now, when you remove the bars, plus or minus radical 2. The great news is that quadratics don't have extraneous solutions, okay? Quadratics, and when I say quadratics, those are functions where the highest exponent is 2. Do not have extraneous solutions. So as long as we do the work correctly, we don't have to check it. So that's great news right there. Example 3. Let's solve this equation. I'm going to start out by subtracting 4 from both sides. So I get x minus 3 squared equals negative 4. And at this point, I've isolated the square. Even though it's a binomial, the square is by itself. So I'm going to take the square root of both sides. Again, when you cancel out the square with the square root, we have to do absolute value around all of that. Now remember, when you take the square root of a negative number, we get that imaginary thing going on. So now we're going to remove the bars and make the other side plus or minus. Now here's where I want you to be careful. When you add 3 to both sides, I want you to put it in front of the plus or minus. And this is just kind of a math etiquette thing. 3 plus or minus 2i. Normally, we would separate the plus and the minus and simplify both sides. You can leave it like this because these are not like terms. You can't combine them. Or if you like, you could do it like this. But you still can't combine them. Not at all. And do one with the minus sign. So you could present it with them separate or together. Either way doesn't matter to me. They're both great. Example 4. Now, I need to get rid of this negative 1/2. So what I'm going to do is multiply the equation by a negative 2. As a matter of fact, I think I want to write that separately so that you can see that a little bit better. Hold on. I'm going to multiply by negative 2 over here and negative 2 over here. I want to make sure you realize I can just do what's in front of the parenthesis. I don't have to go inside. So the negatives cancel, the 2's cancel, and I just get x plus 2 over here, squared. And over here I get negative 10. Alrighty. So now when I take the square root, don't forget absolute value. And here, do any perfect squares go in the 10? Let's see, 4, 9, 16. Nothing goes in, but I still have to take the I out for the negative sign. You never leave that negative under there. So now I'm going to remove the bars. Plus or minus on this side. And notice how I always like to leave a little space in front of the plus or minus. Because I know I'm going to have something there. Oh, wait a minute. I lost my I. Okay, got to get that I in there. So I'm looking at I radical 10. Okay, final answer right there. Alrighty, let's kick it up just a little bit. This is our last example. So I want to solve for x. And as you remember from previous lessons, degree is 2. It's a quadratic. I should have 2 solutions. So I'm going to go ahead and start off by subtracting 2. And I get 5x squared equals negative 2. I'm going to divide both sides by 5. I get x squared equals a negative 2/5. Square root. Ooh, let me say something about this. When I have a fraction, you can decide if you want the negative sign with the numerator, the denominator, or straight in the middle. When I have a fraction, I like to put the negative in the numerator. And when I take the square root, I like to do it separately. And you'll see why this makes it easier. So I could have just done this, but it makes it hard to rationalize the denominator. When you do it separately, it's easier. So here, the square and the square root cancel. I have absolute value of x. Now in the numerator, I have I radical 2. Remember that becomes imaginary. And on the bottom, I have the square root of 5. But let's also recall we don't leave radicals in the denominator. So I'm going to multiply by my magic 1, which is radical 5 over radical 5. And that's going to give me I radical 10, because 2 times 5 is 10. And now on the bottom, that's radical 25, so I can just write 5. Now, when I remove the bars on this side, I have to make this side plus or minus. So that got quite interesting. And it can get a little crazier still if you would have had more than x squared. You know, as a matter of fact, let's do one more example. Let's see, this would be example 6. Let's say I ask you to solve 3x plus 1 squared equals 6. Okay, not too hard. Let's divide both sides by 3 because I'm trying to get the square by itself. And I get x plus 1 squared equals 2. And I just want to make sure everyone feels super comfortable with this process. Okay, we take the square root and we get absolute value of x plus 1. And here, radical 2 is still here. We cannot simplify that. Remove the bars and make this side plus or minus. Subtract the 1. Negative 1 plus or minus the square root of 2. Alrighty. Hopefully that just helped you get a little bit more practice so you can feel more comfortable.